This is very important. Principal value of amplitude or argument theta is interval is this one. I suggest my students like this. Before finding the amplitude or argument, you first note the position of the point representing the given complex number in which quadrant it is lying. Here we find x1, y1. Now we can easily define modulus of complex number and its amplitude. Using complex plane, we have located here P having complex number x plus iy. Now the distance OP, already we know OP is equal to root over x square plus y square. Why? OP square is equal to y square plus AP square means x square plus y square. Therefore, OP is now the distance of P from the origin or pole that indicates the modulus. And that is root over x square plus y square. Therefore, we define modulus and the other symbol is this one, root over x square plus y square. Now, you see the angle made by OP with the positive direction of x-axis in this diagram. Actually, I have taken the point which is lying in the first quadrant, theta. That is the amplitude of the complex number x plus iy. Theta is the amplitude, also called argument of z. Another thing, modulus is also represented by the symbol small r. Later on, we will learn that r indicates radius vector. Here, radius vector is OP, that is why r. Now, if theta be the amplitude and this be mod z or r, then OA is how much? R cos theta. And AP, that is equal to OB, is equal to R sin theta. Therefore, if we divide r sin theta by r cos theta, we get tan theta. Therefore, if theta be the amplitude, then tan theta will be y by x. In common, we write theta equal to tan inverse y by x. Therefore, amplitude z is equal to now remember one thing, this is the preliminary idea, but we have to find exactly the amplitude that depends on the location or position of P. If P lies in the first quadrant, then no problem is there of calculating amplitude, but if theta lies in second, third or fourth quadrant, then we are to be specific of finding amplitude. For that, I suggest learner, students, first of all, you write the complex number in ordered pair form. That means you write x plus iy as xy form. Then you note the location or position of the point in which quadrant xy lies. Accordingly, you are to determine the amplitude. Now, another important thing, there is principal value of the amplitude, and since the point P on the Argand plane can lie in any of the four quadrants, therefore principal value range is this is very important. Principal value of amplitude or argument theta is interval is this one. For that, I explained like this. Student, learner, first you see whether the point P, which is indicating the complex number z, is lying above the x-axis or below the x-axis. If it lies above the x-axis, you are to express the amplitude within 0 to pi, including 0 and pi. If it lies below the x-axis, you express the angle, that is amplitude or argument, within minus pi, 0, within. That means excluding minus pi and 0. To explain that, we are to take few examples. Before that, let me mention one thing. Already I have explained z is x plus iy. Now we can write that I can write z like this, and this is modulus. Therefore, now x by root over x square plus y square. Let me write already I have discussed r cos theta x, from that cos theta equal to this, and similarly sin theta will be this. Therefore, this is therefore the complex number z, when expressed in the form, this is called polar form of z, or modulus amplitude this type of expression z equal to mod z, or you can write here z r, sorry, and this expression is called polar form of z or modulus amplitude form of z. Discussed modulus and amplitude of a complex number. Specifically, I have discussed principal value of the amplitude or argument of z. Now, the general value of the amplitude. That is expressed by this symbol. You note here we have used capital A for general values. That is defined by the principal value of the complex number plus 2k pi, where k is any integer. Therefore, if it is not mentioned, we mean principal value of the amplitude of z or argument of z. Now, if you are required to find the general value, we apply this. Now I am going to discuss few problems related to modulus and amplitude. We are going to find the modulus and amplitude of 1 plus I x plus I y 1 plus I. Therefore, x equal to 1, y is equal to 1. Therefore, if I call it z, then modulus z or mod z is root over 1 square plus 1 square, that is root 5. I suggest my students like this, before finding the amplitude or argument, you first note the position of the point representing the given complex number in which quadrant it is lying. Here we find x1, y1. We see 1, 1 lies in the first quadrant. Therefore, amplitude z will lie, note this, very important. We first express the given complex number in ordered pair form, and we can easily locate the position of that point. We see it is lying in the first quadrant. Therefore, amplitude, actually principal value of the amplitude, will have value in between 0 and pi by 2. This is very important. Note this. Now, x is equal to r cos theta root 2 cos theta equal to 1. Y is equal to r sin theta root 2 sin theta equal to 1. Therefore, if we divide this by this one, then tan theta will be equal to 1 by 1, that is 1 tan pi by 4. Therefore, theta equal to pi by 4. Therefore, finally, modulus z equal to root 2 and theta, that is amplitude z equal to pi by 4. Follow the discussion. First of all, you write the given complex number in ordered pair form as I have written here. After finding the modulus and After observing the position of the point, you write like this. Then apply this. My suggestion is that don't use directly that general form tan theta equal to y by x. If the point lies in the first quadrant, there will be no problem. Now let us take another problem. Example 2. Not like that. The given complex number is -1 -1 minus root 3i. Z is -1 minus root 3i. Then first I find modulus using the formula under square root symbol x square plus y square. Now I mention now -1 minus root 3 lies both negative in the third quadrant -1 equal to mod z cos theta as per the previous discussion. If argument z or amplitude z be theta, then x equal to mod z cos theta, y equal to mod z sin theta. Using that we have got this. Therefore, after division, we shall get tan theta equal to therefore tan theta, first I express using the angle in the first quadrant the value of root theta, tan pi by 3. But the point is lying in the third quadrant, and that angle is to be expressed in negative form. Already I have mentioned. Therefore, this is to be written this matter have been discussed in the topic trigonometrical ratios of associated angles or allied angles earlier. We know tan ratio is positive in the first quadrant and third quadrant, and as the principal value of the amplitude b, when the complex number is above the x-axis, that is to be expressed by positive angle, and when it is lying below the x-axis, that is expressed by negative angle. That is why you see this, very important. Thus tan theta equal to therefore amplitude of principal value of the amplitude will be minus 2 pi by 3. This is very important, students, learner, to note that no problem of getting the modulus. After that, for amplitude, be careful and follow the steps I have followed. You see, after division we are getting positive number. If you don't know the process or the method, you will commit error. For that, you express the complex number in the ordered pair form, that is, or that indicates the coordinates of the point in which we find both abscissa or innate are of negative signs. That means the point is lying in the third quadrant. Hence, theta is to be expressed in negative angle form. That matter I have discussed earlier. If the point lies above the x-axis, then you express the angle within 0 and pi, including 0 and pi. But if it lies below the x-axis, then you express in negative angle form, which will lie within 0 minus. I have followed that and got the amplitude minus 2 by pi by 3.